Okay, hey folks, Mark Locklear here with a screencast on Chapter 10, How to Design a Database. Big, huge, important chapter. In fact, I think we're going to take 2 weeks to cover this just because, yeah, database design is so important. So everything we've done up to this point has been on an existing database, right? And we've been working with the AP accounts payable database that's provided by the Murach book, and then also the My Guitar Shop. And those are well designed databases. I mean, we could sort of dig into the details, and we could probably find some flaws with them if we wanted to, but generally, just sort of, from a general standpoint, standing back and looking at them, they're well designed. But you got to get to that point before you can reliably run queries and do join statements and do all of the stuff we're doing. So that's what this really the next 2 weeks is going to be about, is designing a well normalized database. And we'll talk about normalization some. And I mean, this sort of metaphor, the house being built on a firm foundation is probably a pretty good metaphor for designing a database. And that is, you think about all the things that go into building a house, right? The windows you're going to install, the electrical work, plumbing, fixtures, all of those things. But without a firm foundation, right? Unless the house is well built, starting with the foundation and then the framing and the siding and all of those pieces, like the other things really don't matter. At least you're going to run into problems down the road. So that's a good metaphor for thinking about database design, is that when you're designing a database, you should really take a lot of time to design a firm foundation, or to design a well-built database from the beginning, because again, without that, none of the other stuff is going to matter down the road. And you're going to also run into a ton of problems down the road. And again, to use that house metaphor, things can be fixed. So you can go back and fix things if something's missing, but it's very difficult to do if you run into a problem down the road, as opposed to sort of doing it right up front. Okay. So I just wanted to start the conversation off with that. Let me share my screen, and we're just going to walk through the book. And I think we're probably going to have 2 screencasts this week. I'm going to do one. This is the lecture, and then I will go back and share the entire desktop. This is the lecture, and then we'll go back and also do. I probably have a separate screencast on using our database design tool. We're not going to be using the MySQL workbench. We're just going to use an online tool for that, but I'll do that in a separate database. So let's just sort of work our way through the content here. So when we start designing a database, the first thing we think about is, I mean, the whole point of this thing is to sort of mimic, or databases are designed after real world systems, right? There are systems out there, human systems, that are already in place. They're most likely on pen and paper, although that's less prevalent. I mean, almost every sort of reasonably sophisticated system these days uses some kind of data system. But it may be built on a spreadsheet. It may be electronic, but it may not be a database necessarily, right? Some folks might be using a spreadsheet. They might be using Excel or Google Sheets or something like that. Or again, it could be good old-fashioned pen and paper. But the whole point is that the way we start designing a database is by understanding the system that's already in place. And or if this is a new let's say this is a new company or a new business, the human processes and systems and steps have to be in place before you can actually design a database around it, right? So this is just a good, this page just sort of shows us this idea of people, documents, facilities, other system. Those are sort of all the moving parts and the entities and things that you start looking at, when you first look at designing a database. And so the 6 steps they've got here, designing 6 steps they've got here, identify data elements. So data is really the key here, right? I mean, the processes themselves and maybe the humans that are doing them, and those things aren't as important as the actual data pieces themselves, right? So step 1, identify data elements. Step 2, subdivide each element into smaller or its smallest useful components. We'll talk more about that. Step 3, identify tables and assign columns. Step 4, identify primary and foreign keys. And then step 5, we get into this idea of normalizing the database or normalizing the data structure. And then the last step here is identify indexes. So how do we identify data elements? Well, the example they use here, and this is a good place to start, right, is they're looking at an invoice. This is sort of a physical paper invoice that this Acme fabrication company might have in place. And again, you can imagine a scenario where maybe a company doesn't have a database at all, or maybe they have a rudimentary one in place, and they're wanting to upgrade or replace that. But looking at printed invoice like that is a good place to start thinking about database design. And so, what are the various elements we're looking at here? We see things like we see a vendor name, in this case, custom contraptions. We've got an address, phone number, zip code, website. I'm just looking in the upper left-hand corner. Up in the upper right-hand corner, invoice number, invoice date, terms. And then if we go down in the middle of the page here, we've got various part numbers, quantities, descriptions. And then as we move down, salesperson, accounts receivable, please pay this amount. So we're guessing that's probably a total of each of these part numbers. So these are the ways we're sort of, as our eyes move over this invoice, we're starting to identify various data pieces and also collections of data too, right? And so that where our mind should be going there is thinking about tables and then rows in tables, and sort of where all these various data pieces might fit. And so that's what they've done here, is sort of pulled these various different data elements out. And again, this idea of breaking pieces down into the smallest pieces of data, we'll look at that in the next few slides. So yeah, the next one here is subdividing data elements. So example, we think here, vendor sales contact name. Well, we could just have a contact name field, but often when we want to search, again, we need to be thinking in such a way that we're trying to anticipate things we might want to do down the road, right? So we can imagine a scenario where we're going to want to search by last name. We're going to want to we might want to search and then order by first name, right? So in cases like that, the next logical step is, well, we can't have a single field that has first name and last name, but we actually want to break those up into separate fields, okay? And then same with the address, right? Here, and this is fairly typical. And I mean, I think in 2024, we've all used web forms enough where we've had to enter our data that some of this sort of goes without saying. But I'm old enough to remember a time when you didn't have a lot of data, or data systems weren't as ubiquitous as they are today. So you maybe had to think a little more about it. But needless to say, something like an address, we're going to want to break that up into separate fields. So here they got street and number is in a separate field, city, state, zip, right? So these are going to be separate fields in our database, although we can imagine that these would live in a single table, right? You're not going to break them out into separate tables. You're going to have a single table where the entire address might live. Okay, so how do I identify tables? So now we've moved from individual elements to thinking about tables and columns in those tables. So, again, these were the sort of the data elements that we initially identified inside the invoice we were looking at. So then we can start to pull these out, and maybe we get rid of some of these. So things like fax, web address, contact phone, vendor AR, first name, last name. Some of these things we may not need. So that's a part of this database design process. And again, if you're doing this in the real world, I mean, it could be you out there as an independent developer interviewing someone. But you know, if you're doing this at a high level, or even not even necessarily a high level, but at a medium level, if you're with a company that does this sort of work, there's probably multiple people that you know, the database administrator is going to be the one who's primarily responsible for this job, but you'll probably be interfacing with a product manager or product designer, and they're the ones that are actually interfacing with the actual employees of the company who, you know, are giving you information like invoices and things like that for you to look at. But needless to say, we're sort of covering all of the spots here. So after we've identified tables, columns, we start to think about primary and foreign keys. So again, the idea behind a foreign key is that it uniquely identifies each row in a table, right? And we've talked about composite keys. Sometimes we can have composite keys. Generally you want to just have a single primary key, not a composite key. But that being said, you know, sometimes the situation may warrant a composite key. So here's an example here when we're looking at primary keys. So generally, MySQL or whatever database your system you're using is probably going to use an incremental. Many of the tables are going to use incremental primary keys that are going to be default keys that the database system is actually going to create for you. So in this case, we see here things like vendor ID, invoice ID. Again, we're just entering the information in those tables, and then the database system itself is actually assigning the primary key to those. And then the example of a composite key over on this line item, invoices, we have an invoice ID in addition to an invoice sequence. Okay. The various relationships, we can have one-to-many, one-to-one, one-to-many, and then many-to-many relationships. So at the top here, we've got one-to-many. So in this case, one vendor can have many invoices, and then that's what this little triangle shape looks like here. One invoice can have many line items. Many-to-many relationship here, employees. In this case, employees can have many memberships, and then, or in this case, employees can have many committees. And then we've got this, they call it a linking table. I'm surprised they don't use the term join table, but this is often called a join table too. But employees can have many committees. A committee can have many employees. And then that relationship is made through what we call a join table here. And join tables or linking tables is a term that they use. Generally only have primary keys in their tables. So in this case, this memberships table has both an employee ID and a committee ID. And that's this sort of linking or joining relationship. And then I'm not going to go into, you can sort of read through enforcing relationships between tables. Kind of the big, when we talk about referential integrity, you'll hear about this idea of orphaning data. You often don't want orphaned data. So what that means is, let me go back up to our relationship on the previous page when we talk about orphaned data. You know, in this vendor, vendor invoices and line items scenario, let's say we removed a vendor from the vendor's table, and let's say there was an invoice that was associated with a particular vendor. Well, in that case, you'd have what's called an orphaned invoice, right? You'd have an invoice there, but it no longer has a vendor that's associated with it. Sometimes you'll hear it called a parent-child relationship, and that's the whole orphan thing. But the idea is you never want that to happen, right? When a piece of data, when a piece of data is referencing some other primary key that no longer exists, that's a bad thing. It's a bad thing for the application that's interfacing with the database, and it's a bad thing for the database itself. So, but again, I won't. I'll just sort of leave it to the book to explain that, and you can let me know if you have questions. All right, so let's talk about data normalization. So this idea of data normalization is one where there's a bunch of ways to look at it. I like to look at it as it's a process of making a database efficient. Okay, so what does it mean that it's efficient? Well, it means a couple of different things. One of the main things it means is repeating data. Generally, you don't want repeating data in your database, and I'll sort of highlight that as we go through. The book doesn't focus on that side of things as much, but that's always a key. That's always a red flag for me. If I see databases that are designed in such a way that you see repeating data there, then that's usually a red flag that, okay, from a normalization standpoint, this database isn't sufficiently normalized. And when I say that sufficiently normalized, I say that to say there is a spectrum there, right? And again, we talk about first up through 7, and there are 7 steps, or there's 7 stages of normalization. We're only going to be concerned with the first 3, and the book emphasizes that really the first 3 are the most important, and so that's all we're going to focus on here. I'm not going to focus on normalization steps 4, 5, 6, and 7, because if you go on to do great things in databases, you will learn that either on the job, or you'll get more training or learn that somewhere else. But we're just going to focus on the first 3, the first 3 normal forms. All right. So this is in this case we have an unnormalized database, or an unnormalized table, if you will. And so they're showing us some examples of what that looks like. So in this first example here, we have repeating data. Now in this case, we have columns that are repeating, right? You have, notice there's an item description 1, item description 2, item description 3. And so that shouldn't be. You want this database set up in such a way. And so what that comes down to is you say, well, we've got an item description field here that really should live in some other table, so that it's a row, it's not a column, right? And in fact, if we look down, let's see, terms description. So I don't see item description here, but invoice line. Yeah. So here's the line item description here. But notice the idea is here that moved from, up here we see this as a column to it's actually an item. It's actually a row inside this line item, invoices line item table. And so that's this idea of getting rid of repeating columns or repeating data. Okay. Here we have a table that repeats. And I mean, the other thing here is, if you look at inside the columns itself, notice you've got MySQL add, MySQL flyer. There is repeating data. You've got Android add. There's actually repeating data within a single field, right? So I think scalar is the term that they use inside the book, but each field should be scalar. And what that means is each field should represent a single piece of data or a single item, right? Now, there are such things as multi-valued fields that you can use in MySQL, but we'll set that aside for the moment for, thinking about this idea of data normalization in normal forms. A field should only represent a single piece of data. So again, we're sort of, when we see something like this, where you have more than one thing, more than one entity represented inside a single field, you're breaking the rules of normalization. Okay. And then same thing here. We also see, again, we see data being repeated inside the item description, but then we've also got, notice these vendor inside vendor name, and then in invoice number, we've also got repeating rows there. And these rows are almost you know, these rows are almost identical, right? The item description is different, but the fact that you've got 2 or more rows that have repeating data in it, again, that should be a red flag for you that, okay, I may be breaking some rule of normalization. So in this case, they've given us an example of accounts payable system that is in third normal form. So right here, we've got data that's properly abstracted. Each table represents a single entity in this business process, right? And it sort of makes sense if we think about it, right? We've got vendors, we've got invoices, we've got invoice line items. So this is each item that might be represented inside an invoice. We've got terms, and then we've also got this general ledger accounts, okay? Yeah. And then they talk about items to be indexed here. I'll let the book explain that. Generally, the idea here is that any tables, rows, or columns that are going to be searched with an increased amount of frequency, generally you want an index there. By default, generally, I think MySQL indexes primary keys, because generally when you're searching, those are the keys that you're searching on. But there could be other fields depending on your needs or the behavior of a particular database, where it would be helpful to add an index to fields other than primary keys. But I'll let the book explain that. All right, so let's get into the steps of a little deeper into the steps of normalization. So again, there are 7 normal forms. They sort of go into a little history on these here. Again, we're going to only focus on the first 3 normal forms. Okay, here's a good sentence or 2 description of each of the normal forms. And again, we're just going to look at the first 3 of those. So again, the first normal form, the value stored at the intersection of each row and column has to be scalar. And so that's our term that I was talking about earlier. It must be a scalar value, and the table must not contain repeating columns. And we sort of saw an example of that earlier. Second normal form, every non-key column must depend on the entire primary key. That's this idea of having a single primary key versus a composite primary key. And then third normal form, every non-key column must depend on the primary key. Okay. Yeah. So again, we're talking about the entire primary key. The only difference in those is the entire primary key, as opposed to only on the primary key. That's the difference there is you could have the use of a composite primary key. All right, so let's look at the first normal form. So again, we looked at these. This is the similar tables to what we looked at earlier, but again, in this case, item description here. Notice we've got multiple values in those fields. That's a no-no. Again, a given field should only represent a single piece of data. Invoice data with repeating columns. Again, here we talked about, here we've got an item description 1, item description 2. So like, what if we can handle up to 10 different descriptions for a given item? Well, you're going to be creating columns for each one of those, and that's a no-no. And then and then the example down at the bottom, invoice data in first normal form. So here we've taken and we've got data in each column, but we've broken those out into a single description. So in this case, there's no repeating data in the item description field. We don't have item description 1, 2, and 3. We've just got a single field there, and then we've put each of the descriptions. So we've got a single description in each field there. And now the issue there, looking at second, third normal form, is the repeating data that we have in the other fields. But like I said, at this point, first normal form, all we're looking to do is make sure that each field has a single item. It's scalar is the word they use, which means each field represents a single item or value. Okay, applying second normal form. I sort of highlighted this, and let me read the note that I put here. So another way to read this, I'm going to read through what they have, and then I'm going to read my note. And so let's just, as I read this, let's process it together. It says, now consider the three non-key columns shown in this table. And so before I do this, let me highlight. So this is the table in question, and let me use, I'd like to be able to look at this. See if I can orient my screen so we can see both of these. So it says, now consider the three non-key columns shown in this table. It says, of the three, only one item description depends on the entire primary key. So if we look here, item description is over here, and that's really the only one that depends on this invoice ID key, right? Vendor number, invoice sequence don't. The other two, vendor name and vendor number, depend only on the invoice ID column. Because of that, these columns should be moved to another table. The result is that the data structure, like the second one shown in this figure, we'll look at that in a second. Here, all of the information related to the invoices are in the invoices table, and all the information related to the individual line item is stored in an invoice line item table. So again, the idea here with this table that we looked at is, notice you've conflated, or you're combining a bunch of data that really should be abstracted out or should be separated, right? We've got things like the invoice, we've got things like the vendor, we've got item description. And so the idea here is that we want to break these out. And I just put this note here. Let me read this. Another way to look at this, another way to say this is that the non-key columns that contain repeating data, so in this case, vendor name and invoice number, should be moved to another table. And again, they don't make this 100% clear in the book. But again, if you look at the vendor name column and the invoice number column, the fact that we've got repeating values there is a good red flag to say, maybe this should be data that should be pulled out into a separate table. So I just wanted to make that point. Let's close. Okay. So let's look at, on this next screen, we'll look at those tables. So yeah, so in this case, we've pulled out, so the invoice data is in the second normal form, and then we've pulled that out into this invoice ID table, or I'm sorry, this invoice table that has an invoice ID, invoice number, and then vendor name. All right. And then if we look, so that's second normal form. And then if we move over to third normal form, then we end up with, we've got so in this case, what we're seeing here is second normal form. And then let's see what third normal. Well, they don't give us the example of third normal form. Actually, I think they gave that farther up. But this is third normal form here. Now we've got a bunch of other, but if we focus on vendors, invoices, and invoice line items, notice the vendor table has all of the data that's related to the vendor, right? Name, address, zip code, area code, phone, so on and so on. Invoices has a relationship to vendors based on vendor ID. So that's the primary key. And then we've got all the data that's related to the invoices here. And then finally, the invoice line items. So an invoice can have multiple line items that live within it. So we've broken that out into this invoices or invoice line item table. And that has things like quantity, price, and description. So again, think about invoice, a larger invoice. Think about when you go to the grocery store, right? You check out all of the items there. Those invoice line items would be each of the items that you purchase, right? You might buy 3 containers of yogurt. So in that case, you'd have a single line item that represented those 3 things, right? That'd be the line item quantity, and then the price of each of the yogurt you bought, and then you might have a description there too. And so that would be all of the yogurt you bought. If you just buy a single can of soup, let's say again, you're going to have a separate invoice line item for that, but just with a quantity of one. Okay. And then I'm going to stop there. So that's on the design side of things. Again, I'm going to do a separate screencast on our design tool that we're going to use. We're not going to use MySQL Workbench, but it has the same features that MySQL Workbench has. So now you're armed with this information. I guarantee you're going to look at the world a different way now. And when you go out in the world, just think about all of the processes that are out there. So when you're at the grocery store and you're checking out, think about what a database table would look like for that, right? When when you get in your car to drive, think about what would a database look like that would represent the manufacturing of a car. Think about all the parts that go into a car. What would a database look like for that? When you go to church, what would a database look like for that, right? The church might be the database name. There's members, there's hymns that you sing, there's an offering that's sent around where folks give money. There's a sermon. I mean, just you can really take any entity, that's out there and break that down in such a way that you can encompass it in a database. And I do the same thing if you have my Java or my C++ class. In the programming world, in the general sort of programming world, we talk about object-oriented programming. Object-oriented programming has the same concept, right, of taking these real world processes and things and then encapsulating them in again, this idea of an object-oriented program where you're taking code to represent these entities that live in the real world. So I'll stop there and I'll do a separate screencast on the database design tool that we'll be using.